Okay, so our last special situation when we're multiplying a binomial to a binomial. This situation is called the perfect square trinomial, and it creates another situation that we'll have to explain the name when we get there. And again, there's another pattern to see in all the examples that I have. Notice what I've got going on is I've got a sum being squared, right? And so I'm basically taking the same binomial, right? To square something means to multiply the base to itself. So in all these cases, I'm multiplying the same binomial to itself, right? Even in the subtraction statement. So that's the first thing to establish in this pattern, is we're basically squaring, all right, a binomial. And so once we do that, we multiply it to itself. So since we don't know the pattern yet, let's go back and rely on good old FOIL, right? You can always rely on that. So if I FOIL this out, x times x, right, first would give us x squared. Then what I get is the outer is a 3x, the inner is a 3x, and then the last gives us a 3 times 3 is a 9. And then this time, because the sign is the same, the outer and the inner actually end up doubling each other up, right? So I'm going to write it this way for a moment, right? So 3x and 3x, well, that's double 3x. And of course, you guys are probably thinking at home, well, isn't that just x squared plus 6x plus 9? All right, but I'm trying to get us ready for a little item. And so there's basically our perfect square trinomial. And you'll notice that the pattern also, not only is this term being doubled up, but the first term is being squared and the last term is being squared. So essentially what I have, right, is x squared plus 2 times 3x plus 3 squared, right? And I'm trying to establish a pattern there. So let me go ahead and kind of show you that. So if this pattern holds, right, what I'm expecting is to get the first term squared, right? So that's 2x squared. And 5 and 2x, right, the outer and the inner, that basically doubles up. And then 5 times 5 is 5 squared. So there's basically the pattern that I'm trying to get you to see. But of course, since you guys probably don't see it yet, let's go rely on FOIL. So if I FOIL this out, 2x times 2x, well, there's my 4x squared. My outer gives us a 10x. My inner gives us another 10x. And then my last times my last gives us 25. And so you'll notice again my pattern. There's my first term being squared. 10x and 10x, well, that's basically doubled up. And then 25 is basically the second term squared. So we get 4x squared plus 20x plus 25. As a matter of fact, if I work that out, right, 2x squared, well, everybody gets raised to the second power. 2 times 10x is 20x, and then plus 25. So it's kind of a harder pattern to use because there's a lot more going on than just the difference of squares. But once you see it, it's again another shortcut. Rather than doing all this, right, you just basically establish the shortcut. So let me do it again, and then I'll reestablish it with FOIL. So again, I'm seeing that I've got a sum being multiplied to itself. So the pattern says we're going to take the first term and we're going to square it. And then the outer and the inner, right, which would be 12x, is going to be doubled up. And then 4 times 4, right, we're going to square the 4. And so my answer would be 9x squared plus 24x plus 16. So it's basically my perfect square trinomial. And I'll come back to why we call it that in a moment. And then, of course, if you FOIL this out to check to make sure that you can trust the pattern, first times first, well, there's your 9x squared. My outer is a 12x. My inner is another 12x. And then 4 times 4 is 16. And so you can see that the outer and the inner is basically being doubled up. The first term is being squared, and the last term is being squared. Combining like terms, we get the same thing. All right, and so why are we calling this a perfect square trinomial? Well, notice that the result in all these multiplications is in fact a trinomial, right? And this trinomial was built by taking a square, right, of a sum, right? And so it's a nice perfect square trinomial. And so if you keep following that pattern, throwing some A's and B's at you, right? The pattern, I'm taking the sum, so literally this is A plus B times A plus B. But if you're starting to trust the pattern, this is the first term squared. We're going to take A and B and double it up, and then we're going to take the last term and square it. So first term squared, double up their product, and then the last term squared. I kind of say first term squared, last term squared, doubled up in the middle. All right, so whatever acronym it takes to do that. And so you're looking at what is famously known as our difference of squares pattern. All right, and this is for a sum. Okay, again, when in doubt, if you don't like the pattern, if you don't really want to use the pattern, as I've noticed, you can, or shown, you can always rely on good old FOIL. Okay, just make sure that you're multiplying the same base to itself, and then you're back to FOIL. So this is the sum pattern. What about a difference? Well, the difference is basically going to be the same thing. So I'm kind of working in reverse here. So let's start over here. So if it follows the same pattern, because it's now subtraction, rather than doubling up and adding the outer and the inner, we're going to double up 3 times that, 3x. But it's going to be a subtraction. So let's just see that happening here. So I'm expecting an x squared minus 6x plus 9. So again, I'm kind of using the pattern I saw here, but with a difference. So let's just rely on FOIL to show it. So first times first, well, there's my x squared. My outer is a negative 3x. My inner is another negative 3x. And then a negative times a negative is a positive 9. And so you can see we're basically doubling up, right? We're subtracting the same term. So we're basically subtracting double of 3x. And if we combine like terms, right, there's our other perfect square trinomial. So there's a perfect square trinomial for a sum, and there's a perfect square trinomial for a difference. Okay? Again, if I establish the pattern, I see a difference. We're talking literally 2x minus 5 times 2x minus 5. So we're going to take the first term and we're going to square it. We're going to take the second term and we're going to square it. And then we're going to subtract twice their product. Well, 2x and 5 is 10x. So if I use the pattern, I'm getting an answer of 4x squared minus 20x plus 25. Of course, if you don't trust the pattern, you want to FOIL it. 2x times 2x is 4x squared. The outer is a negative 10x. The inner is another negative 10x. And the last times the last is a positive 25. Doubling up the middle term, there's your answer yet again. So the answer via FOIL or the answer via my perfect square trinomial pattern for a difference in this case. So again, looking at it as a formula, this is a minus b times a minus b. And we're going to take the first term, we're going to square it. We're going to take the second term, we're going to square it. And then we're going to basically subtract double their product. And so that establishes our next perfect square trinomial pattern formula, if you would, for a difference. So there's two different perfect square trinomials. Are you squaring a sum or are you squaring a difference? All right, and they're very similar. Squaring the first term, squaring the last term, twice their product in the middle. All right, if it's an addition, we're adding that double the product. If it's subtraction, we're subtracting double that product. All right, and it looks like I missed one up here, but it's a sum, right? It's a perfect square trinomial. So using my pattern, it's the first term squared, the last term squared, and we're going to add their product in the middle, right? So 5x and 2 results in a 10x. And so we get a 25x squared plus 20x and then plus 4. And I'll let you check that out with the FOIL. So that pretty much exhausts all our special products with a binomial. In sum, we have, going in reverse, we have perfect square trinomial situations. We have difference of squares situations. And then we have just the good old FOIL process itself. And that should wrap up 4.6. And we'll got a couple more sections to cover. I'll see you in those videos.